Hello, everybody. Welcome to today's webinar, 3 Reasons to Select Series Platforms for Cloud Native Application Monitoring. Today's webinar is hosted at devops.com. Content is brought to you by InfluxDB. So I'm very excited to go over this topic. I think that Tom from InfluxDB is going to talk about some really exciting stuff. And we'll have some back to forth on the concepts that we cover here. But before we get going, this webinar, you can hear us, but we can't hear you. So if you have any questions, you'll see a question dialog in the GoToWebinar panel. Type your questions there, and we'll try to get to those at the end. If we don't get to them, then InfluxDB will get back to you with responses to your specific questions regarding the platform and technology. The other thing is that this webinar is recorded. So make sure that you share it with your peers. You'll get a link to the webinar after it's over within a day, and you can share that link with your coworkers and so forth, because there's going to be a lot of really strong content here to go over. So Tom, I know I have control of the slides right now, so you may have to just let me know when to advance them, but I want to introduce Tom Crow from InfluxDB.
Hey, thanks so much for having us, Chris. We're excited to be here today.
Great.
All right, let's kick it off. So today we're going to be talking about why you should be using time series platforms for monitoring your cloud native applications. And as you're looking at some cloud, can we go back? As you're looking at adopting things like Docker or Kubernetes for your orchestration, or you're bringing DevOps a little more into your organization, one thing that we're consistently seeing is that those archaic monoliths are being broken down, and we're exchanging those for these microservices. The same monitoring solutions that you were using when you had, one monolith on-prem that you were monitoring just aren't working the same for these new cloud native application architectures. They're not able to keep up with your scalability. They don't have the usability or the responsiveness that you need. They're not built for mobile or IoT needs that we see. So people are developing and coming up with new ways to monitor that give them the data that they need. Whether you're going low code or you're building a platform on your own, you're going microservice route, you're building everything on serverless. In any case, we know that you need to be monitoring this stuff, but it's not working well with what we have existing. Next slide. And we know that you're going to be monitoring all sorts of new things, your DevOps tool chains, your containerized apps. In addition to the containerized apps, you want to monitor the containers. You want to monitor every stage of your Kubernetes cluster, the nodes, the pods, and you need a new way to look at this. Let's go ahead and look at the growth of Kubernetes, for example, on the next slide. Kubernetes is huge, as you know. It's the #1 way that people are orchestrating their application development. And you can see here by the sheer number of users and the adoption that it's left all of its competition like Cloud Foundry in the dust. The big question is, how do you effectively monitor so that you can scale, you can identify problems, you can find memory leaks, you can identify those bottlenecks and resolve them, and everything else that goes along with monitoring a modern application. You've got the orchestration figured out. Now we need to add monitoring to the equation. Next slide, please. So why you should care about better monitoring, you really need to focus on uptime with any modern cloud native app. You want them to be running all the time. So you're going to need that sub-second visibility into your architecture. We have customers who are coming to us who have legacy monitoring that's, only pulling in data every 10 to 15 seconds, or in some cases, like one of the use cases we'll probably talk about at the end here, they were only getting 15 minutes of granularity. When you're trying to keep your web app up and make sure that everything's working, 15 minutes or even 10 to 15 seconds isn't going to cut it. You need to be a lot more granular to make sure that everything's working the way it should. As we hit on briefly a minute ago, our cloud native apps are so much more complex. These ecosystems of microservices, they require cross-level domain visibility, and that's not what other monitoring solutions are built for. And then thirdly, we need to be able to scale. These complex infrastructures are creating just huge volumes of metrics and events. If you're ingesting millions of metrics every second, what you were using 10 years ago is just not going to work. So let's, next slide. Because of this need for granularity, we've seen time series platforms emerge. They're built to ingest and process. They're built to ingest large amounts of data to process in real time and give you access to that data on demand as you need it.
And before I advance, Tom, it was funny, right before the webinar, we were talking about, Kubernetes at times being over-engineering of a problem, but it's really, a lot of organizations will think about using the tool for building their applications without considering, what it takes for visibility and what it means to actually manage that aspect of it. Is that also what you're seeing, is that organizations just don't anticipate or think about these challenges? They just kind of dive in?
Absolutely, 100%. Like Kubernetes is built with Prometheus built in, and people think that's going to give them all that they need, but they learn really quickly that there's a lot of visibility that they're not getting. There's a lot of data that they're not able to capture, and they're seeing, they'll see performance issues, they'll see apps go down, or parts of apps go down. And you really, as you're looking at building with Kubernetes, like you said, for a lot of people, it probably is overkill, but no matter what, if you're using it, you need to see what's happening, and you need to be able to follow along with and find all of your problems. Those bottlenecks can be huge. And one of the reasons that we're seeing this issues with things like modern, like cloud native apps who are using Kubernetes and everything, is just the sheer workloads that we're pulling in now, right? We also talked right before this about, for example, IoT and cloud native apps. So many of the cloud native apps we're seeing built right now are using connected things out in the world. They're pulling millions and millions of metrics and events from devices, some of them at the nanosecond level. And if those listening, if you on the call are like most of us, if you look down at your watch, you've got a connected device that's capturing time series data. If you've got your Fitbit or you've got your Apple Watch, those are collecting data. If you're monitoring anything that has to do with the sensors on any of your servers, or you're monitoring your DevOps, your disk usage, all of that's connected, pulling in so many more metrics as we're looking at the instrumentation of the virtual world, monitoring those dev tool chains. It's tough to have a product that can keep up with all of that. And really, it's not just the DevOps toolchain. When you're looking at the underlying cloud infrastructure, your containers and your orchestration, the amount of metrics you need to be able to monitor grows exponentially. And what we're noticing is that these metrics and events that are generated by new application architectures like cloud native, they're growing, and there are these new workloads that need a different solution. Next slide. And metrics and events aren't new. If you've been in the development world for any amount of time, we've been collecting metrics and events for years and years and years. But what is new is the scale, and that's what time series platforms help with. We're looking at within the time series platform, these metrics and events are all time series timestamp data. We're pulling in regular events, so things that like weather data, where you're pulling in the temperature, barometric pressure, all of that at a regular interval. That's a metric. And events, things that are triggered. So something goes wrong within your app, or you have a spike in usage that alerts. Those are being pulled in at irregular, and those are our events. We're pulling in huge volumes of data, as I've said. For some of the developers we've talked to, they're pulling in tens, hundreds, or thousands times more data than they were 10 years ago. Next slide. So what makes time series platforms different? They really, like we said, the time series data isn't new, but the scale has come to a point to where we need something that can really handle this data that we're bringing in. There are unique requirements with the time series platform that you're not going to see with your traditional relational databases, your graph databases, your search databases. Stuff like high ingestion of large volumes of metrics. And when those metrics are coming in, you're going to need to be able to pull those queries, query that large data set in real time. And in order to save space and not, house all of this data forever, you're going to need to come up with a way for eviction and transformation of data or downsampling of high precision data. And then you need all of that data to be stored and compressed. So, can we go back real quick? What I was going to say is on top of the high volume of writes that we're getting, time series data can also handle a large number of, like InfluxDB, can handle a large number of simultaneous queries. So you can also get rid of a large amount of volume of data, which you don't need anymore, or you can downsample that high precision data, like I said. So you can take, for example, all of the, if you're following, if you were following real-time analytics, you're following how often Apple stock changes, for example, over time, or a market changes over time. You can downsample that and you can average it so that you're looking at at the changes every minute or every 5 minutes, and that's a lot less data. But really what we're building is we've built the time series platform, and all time series platforms are built to bring in those high volumes of data that can be optimized, compressed, downsampled. All right, next slide. Thanks, Chris. And time series is just as in demand, if not in demand, more in demand than other types of databases that we're seeing. Right now we're seeing time series growing faster than SQL databases. It's outpacing search databases and definitely outpacing big data stores. Time series databases are growing much faster. And if you look at like DB engines, you can see the rate at which these are growing. And how popular time series is right now. Next slide. So now that we understand a little bit more about what time series is, let's look at what InfluxDB is. And InfluxDB is the platform that we built here at Influx Data, and it provides a modern engine for events and metrics. We designed it to be easy to start. Next slide. It's built to help you instrument, observe, learn, automate any system and application that you have. Here you can see as a high-level overview of what happens. InfluxDB is ideal for all metrics and event workloads. The data comes in from all of your data sources, from your IoT or IIoT devices, from your infrastructure, from your business metrics, from any sources that you can imagine. It's processed and stored and used for things like monitoring, analytics, tracing, machine learning. Next slide. So here's an example, here's a look at the tick stack, which we've created. It's called the tick stack because it's composed of 4 open source projects that we built: Telegraf, InfluxDB, Chronograph, and Capacitor. And just as a quick overview, Telegraf is our largest open source project that we have out there. It's used, it's pretty common among developers. Chances are most of the people on here have used or at least heard of Telegraf. It's an agent for collecting and reporting metrics and events. Brings data into InfluxDB, which is our storage component. And then from there, the information can be visualized in Chronograph, and then you can set
Hey, Tom, it looks like we lost audio with you, so hopefully you can hear us or reconnect via the audio.
There we go.
There you are.
Sorry about that.
And he's back.
Internet. Let's go to the next slide. Telegraf, like I said, is our agent for collecting and reporting metrics and events. It's a plugin driven open source project. What it does is it'll grab data that you're collecting from any number of sources. We have 200 plugins that are pre-built that you can use, or you can build your own plugin to pull in from legacy applications. It'll pull things like your Kubernetes stats, Prometheus endpoints and service discovery. It'll pull from your networking setup. It'll pull message queues from your apps and databases and system stats, logs, and traces. As well as, like I said, up to over 200 third-party APIs. With these 200 plugins that we have built in, it's the most complete plugin framework in the world. It makes us the most deployable option out there for cloud and cloud native architecture, because it combines your cloud metrics and events with those legacy metrics and events that you want to collect, giving you full stack monitoring. The way Telegraf is designed, it has 4 concepts for distinct plugin types. One is input, so this is collecting those metrics from your system, from services, or those third-party APIs and bringing them in. Processor plugins that will transform or decorate or filter out metrics. So if there's only a certain amount of information that you want brought in, you can set it up to do that. Aggregator plugins, which will create the aggregate metrics. So if you want, as data's coming in, if you want it average, or you want to find the mean of it, you want to find the minimum or maximum or quantiles or any of that, you can do that. And then output plugins, which work exactly like input plugins, but in reverse. Next slide. Once the data comes in from Telegraf, it typically goes to Capacitor or InfluxDB, and InfluxDB is that time series database that we built. It is built from the ground up to handle the high write and query loads that you need for time series database. It's super performant data store. It's bringing in all of your metrics and events from anywhere that you have, from your DevOps monitoring, from application metrics, IoT sensor data, real-time analytics, anything that you're collecting that's time stamped. And it's built to be performant, to be fast, and to conserve space. So you can keep your data for the defined length of time that you want. It'll automatically allow you to expire things, and you can delete any unwanted data that you have. And to make it even easier, we use a SQL-like query language for interacting with your data. Next slide. Data can also come into Capacitor from Telegraf or InfluxDB. And Capacitor is that real-time streaming data processing engine. It lets you process both stream and batch data from InfluxDB. It uses a plugin custom logic or user-defined functions. So you can set up alerts with dynamic thresholds. You can match metrics or patterns. You can compute statistical anomalies or perform specific actions based on these alerts, like dynamic load rebalancing. And what's great is, since it does have that user-defined function option in there, you can utilize your existing functions that you have elsewhere. You can bring them into Capacitor, so you're not reworking your entire system, so that you can get the data process that you need to. And then from there, it integrates, it helps with things like anomaly detection, machine learning, or service discovery as well. And the alerting function integrates with things like Slack, HipChat, OpsGenie, Sensu, and Alerta, and PagerDuty. So all the major alerting frameworks out there can get data from Capacitor. Next slide. And then we have Chronograph, which is that visualization component that we have. Within Chronograph, you can build dashboards like this one, for example. This is a Kubernetes dashboard that's pre-built. So once you connect your Kubernetes instance to Chronograph, you can just click a button and start viewing this. It helps with the visualization and dashboarding. It's also got a data explorer, so you can look at raw data. It's got a query builder, so you can click and build the query you want from the options you have, or you can write the query in Flux, our query language. There are templates and libraries to make things super easy, and then you can also set up alerting and automation from right here. Next slide.
Yeah, and Tom, I wanted to ask you, so this is a struggle, in the market at large, and a question that actually came up, and I think I'm glad that the attendee asked this question, is with all of these components and options, how would you recommend that an organization start to frame their strategy for picking a tool Do they look at their use case? What are some ways to kind of assimilate all of this great stuff and make a decision about what to use?
So that's a great question, and it's a really hard thing to do, because one thing you'll learn is as soon as you start collecting metrics and events from places that you're not currently right now, you're going to realize quickly that you want more and more and more data. So you need to find a solution out there that can grow with you, something that can grow horizontally and vertically as you grow, that can bring in more and more metrics, and look at what you want to monitor. So if you've got a DevOps tool chain that you want to monitor, and you want to monitor your Docker and Kubernetes, as we're going to explain here, and you've got some real world data that you want to monitor. You want to see, for example, if you want to see how your system performs, like Wayfair, we're going to discuss later. They look at a lot of different factors, internal and externally, and they need something for monitoring that can aggregate all of that. I might be a little partial when I say Influx is the best option for that, but I really do believe it, which is why I joined the Influx team. You're going to want to be able to, you're going to want something that takes care of everything. You don't need to start orchestrating 37 different tools to make something work. So for example, with whatever you're using, Telegraf is an open source plugin that can pull those. You'll want to, I always recommend using Telegraf as your starting point. Then start playing with different solutions. InfluxDB, for example, is open source, so you can start with the open source solution and see if it meets your needs. But even easier is our Cloud 2.0 offering. There's a free version right now. The free version comes with a 72-hour retention policy, so it's just used to kick the tires or for a small project. You're not going to use it on your enterprise level, but it'll give you an idea of what InfluxDB is capable of. If it were me, I would give InfluxDB a try. Start with that Cloud 2.0 offering and just see what data you're able to pull in and make sure it works for you.
Yeah, and the great news is all of these, these tools are really easy to get set up, even for a guy like me, because we were just talking about I was doing a setup with my small little dorky server I have in my basement. But one of the things that you mentioned that I think is critical is thinking about the future. So don't just adopt a tool for the challenge that you have right now. You also need to think that it needs to be extensible as the next evolution of technologies or applications come out.
Absolutely, absolutely. And to go along with what you said, I really don't want to make this sound like a sales pitch, but because that's one of the worst things you can get on a webinar. But I will say, we did a workshop last week before DevOps Days, Minneapolis, and on that workshop, we wanted to get people up and running on Cloud 2.0, and I had used our open source offering. I hadn't really done anything with cloud, but as I was building the workshop, I wanted to time how long it took to get my Cloud 2.0 account set up and then start ingesting data and being able to query and visualize. So the workshop built on pulling system data from your computer. So I set up my MacBook, and from the time I set up my account, downloaded and installed Telegraf, and was pulling in data was 3 minutes. So I was able to have my chronograph dashboard up and running and showing system performance in 3 minutes, which is pretty impressive. So it's a great way to get to test something out without spending a whole lot of time and investing to make sure it's going to work for you.
Yeah,
since we are talking cloud native, let's be honest, cloud native for a lot of people incorporates Kubernetes and Docker. And this is an example of how you can ingest data from your cloud native app and how to use InfluxDB with different stacks. So here we have the Kubernetes master node, and we have a node with 2 pods set up. And you'll notice with the master node, we have a Telegraf as a coming in from the master node, and then on the first node, we have Telegraf set up as a daemon set, and then we have sidecar instance of Telegraf on both pods. So we're pulling in data and able to get consistent metrics from Telegraf for the nodes and the pods. Telegraf uses one thing that's good about Telegraf is it does a push-pull. So in this case, we can implement push-style metrics for the whole cluster as well, and it all comes into InfluxDB, and that gives you that helps you gain your consistency in metrics. You've got the long-term storage and high availability option here. And as we said, it enables push style metrics that you're not getting natively with Prometheus. If your application is deployed on the pod in a container with Docker, you can pull data from that as well. You get application metrics, Docker container metrics, your Kubernetes metrics, and any other metrics from your infrastructure or your application that you want to pull in. A good example of this, Microsoft has Telegraf deployed as a daemon set on over 500 of their nodes. Next slide. And since we are talking cloud native and Prometheus is king when it comes to Kubernetes, we want to show how InfluxDB can run alongside of Prometheus, can augment Prometheus and add more metrics to it. So one thing that a lot of we've heard from users that they've learned is that with Prometheus, they learn that they hit some roadblocks with Prometheus, right? It doesn't have long-term storage. There's no clustering. There's no high availability. Security isn't built in. So it's not really always suitable for the enterprise needs that you may have. So what we recommend is putting Telegraf in and letting it sit side by side with Prometheus. Since Prometheus is good with Kubernetes, it's built in natively. InfluxDB is good for your enterprise-wide needs. So you can pipe your Kubernetes data into Prometheus. Telegraf can monitor those Prometheus endpoints, and then you can ingest your info into InfluxDB and bring in non-Kubernetes data that you're monitoring as well to give you full stack monitoring. This is where we were talking earlier about people who've already adopted Kubernetes and are realizing they need more information. That's one of our big use cases. Basically, chances are if you're running Kubernetes and you've got your Prometheus running, you've got a huge investment already. You've spent a lot of time and effort setting all of that up. Well, this is going to save you time because you're not going to destroy that Prometheus investment that you have. You're going to continue to use it. And it'll help you in some areas where we'll talk in a minute about how it helps Kubernetes a little bit more. But let's go to that next slide so we can jump into that. So if you have Prometheus, why would you want InfluxDB? Again, we talked about this. It'll help you monitor your Kubernetes instance plus your non-Kubernetes. You can pull in from those 200 plus plugins that we have to provide visibility across your entire infrastructure. And let's just be honest as we're talking about this. We're talking cloud native specifically, and cloud native is great. But if you have a company that's been around for any amount of time, chances are your whole enterprise situation isn't cloud native. You've got non-cloud native apps running, and you want to pull in metrics and events from those as well. And InfluxDB will help you do that and put it all in one place. Clustering and high availability doesn't come with Prometheus. Prometheus has ephemeral storage. You can combine what we have to create long-term storage solution with high availability to complement Prometheus. Since there's no dedicated organization within Prometheus, one thing also that comes up from time to time is the lack of security features needed for enterprise solutions. InfluxDB can help with that. And since Prometheus only does pull without a push option, we can push those metrics. So that becomes an instance. Let's say you've got Kubernetes orchestrating, and Kubernetes spins up 4 pods, and 45 seconds later realizes 2 of those pods are no longer being used. It kills those pods. There's a chance that Prometheus and any legacy solution you have did not pull any metrics from that. So you don't know what happened in that 45 seconds. You don't know, you can't plan for the future based on what you saw there. Well, with InfluxDB, since it's got that push-pull feature, you can still get that information. InfluxDB handles security and alerting. We give you that fine-grained security and real-time analytics and alerting built in with the InfluxDB platform. So it's really a perfect complement or stack to extend Prometheus. We talked about the metrics and events there. Prometheus is great for scraping metrics, but it's not good for events. So Influx will enable that level of metrics and events to come in, further blending your business context as you need it. So it'll also preserve your investment in Prometheus. We don't have to change anything. We'll just read those Prometheus endpoints, and it'll require no changes to get more monitoring built into your application. So next slide. Really, we've got service operators out there using familiar kubectl commands, we're able to pull in native HashiCorp Terraform modules, and Helm charts are built in. In a nutshell, if you want a single platform for all of your metrics and events for everything that you're doing, cloud native and non-cloud native applications, and Prometheus isn't able to deliver that, InfluxDB can work with Prometheus to build that full stack monitoring that you need. Let's look at a few use cases here. Next slide. So we're going to start with Wayfair, like I said. And Wayfair, they've got a really interesting use case. Wayfair is using InfluxDB for all of their, to monitor all of their system and metrics events across their data centers. Let's go to the next slide. Here's an example of what Wayfair's doing right now. Wayfair is using InfluxDB, and the use case we're going to talk about specifically is their Cyber 5 holiday weekend. So any of you who are familiar with Cyber Monday and Black Friday and all of that good jazz that happens on the internet, you know, a lot of people hit the web and start shopping. Well, Wayfair sees a huge uptick in their web traffic, and they're monitoring their data centers. They have hundreds of apps that are running and sending metrics to InfluxDB. They're pulling in over 20 million real user measurements at any time across 8 stores. They've got hundreds of pages, thousands of types of devices that they're monitoring. And they've worked with InfluxDB to ensure that they've implemented InfluxDB correctly, that it's scalable and robust and in line with what we're doing in the future. And what's been great for us is that they're providing us feedback to help drive our next generation of InfluxDB enterprise features. Let's look at what their architecture looks like. So this is what they look like when they had 3 data centers. They're up to 6 right now, but they have a multi-layer pipeline with Telegraf. They're receiving all of the raw influx data through line protocol, which is our protocol for ingesting data. They're using UDP and forwarding it onto Kafka to get all their data in. They're consuming the metrics from Kafka buffer, and then they're writing those to InfluxDB. At that point, they're connecting all of their data centers together and mirroring Kafka topics. They decided to use UDP because it's fast and non-blocking, and they use TCP because it's more robust. They're able to ingest a lot of data from a lot of different sources really quickly and put it into InfluxDB. And they tell us that this has given them a multi-day tolerance for any major issues that they have. And what they were using before, let's switch to the next slide. They replaced Graphite, their Graphite instance, with InfluxDB. And they hit a lot of limitations with Graphite. It didn't have clustering. The storage infrastructure was difficult to manage. It took a lot of work. They didn't have any data pipeline out of the box. They really maxed out its potential and performance. And with no shard relocation, backup or restore, they were pretty nervous about what would happen if they had any sort of outages. So they brought in InfluxDB because of rapid performance improvements and hardening. The clustering was a pretty big deal. They liked the fact that it was written on Go, so that they could use it in multi-core in several of their environments. They liked the fact that it was built with efficient and scalable storage. They're really supportive of our community. They like the fact that we had an open source community, and they've been involved in our open source community and actually run one of our biggest meetups that we have in Boston. They take care of everything every month for that, just because of their love for InfluxDB and time series data. And then they are growing their customer base from a diverse set of companies. The fact that we're pulling in all these different types of companies, we're able to share how those companies are using InfluxDB, some new use cases, and giving them ideas on other data and metrics that they can pull from. All right, we're gonna look at one other use case, because right before this we were talking, Chris and I were, and oh yeah, let's actually start here, about how we're pulling all this different data together. One of our customers is this company called Playtech. They create 50 multi-branded sites that basically are online gambling sites. Let's go to the next slide. So that creates some unique situations for them, since they have all of these sites that are around the world. They have to be able to handle financial transactions in hundreds of markets that are all regulated. And InfluxDB has become a major component for them. They use us for all of their monitoring, from their low-level monitoring, all of their CPU, disk, memory, networking, all of that stuff that you need to for your DevOps chain. They're able to also use us for their high-level monitoring. They're tracking everything their users are doing from within their app. Everything that in their app is all in the cloud, so they're able to track everything the users are doing, and they're also using us for their organizational level monitoring. So they're mapping their portfolios, they're tracking their clients, their sites, their brands, and tying it all to an internal org chart so they can see who is responsible for what. And let's look at their architecture as well. It's a different architecture than what Wayfair has. Each architectural diagram is going to be different. Each setup is going to be different. Theirs is predominantly service oriented. So the components they have an extremely complex business logic that they follow. They've set up ways of defining their boundaries and responsibilities for each component, so that way they can add new things independently on the fly without a fear of breaking anything else. So if they want to release something new, it's not tied to 30 other things that could possibly break. Their microservices are all executed on their own Python virtual machines, and everything has an event-driven design. All communication goes through message queues, and the system works asynchronously. Anything that happens, any issues that arise, they're able to then notify the correct person or department. And they're coming from, next slide, please, HP's Service Health Analyzer, which is how they were collecting data before, and it was just this big black box. It was impossible for them to change settings or fine tune anything they needed. They were hitting a lot of false negatives and false positives, and this is one of those instances where I talked earlier about granularity. They could only see things at a 15-minute granularity, and that just doesn't fly for cloud apps. It just wasn't doing what they needed to do. It was trying to be a universal instrument and didn't work. So they liked InfluxDB. They wanted a time series database for any and all metrics. They liked the fact that it was widely adopted by the community. They said it's fast and reliable for them and comes with great support. Chris, do we have time for one more use case, or do we want to move on to questions?
I think we should do another use case.
Okay.
Because it's always good to hear, how technology is used in the wild.
Okay, well, let's go ahead and talk about that. Let's talk about one more, which is where you and I were talking earlier about IoT and DevOps meeting for cloud native design. There's a Belgian biomass plant called ANS Energy, and I'm going to do this all from memory, so without a slide. They're presenting that classical IoT challenge. They've got these huge machines that cost a ton of money, and their industrial equipment needs to last. It needs to be performant for decades, right? They had a data historian that they were using that, well, I say they were using. It was kind of again, that black box. It wasn't easy to use. They weren't able to pull data from it. They still had operators who were writing down their counters on paper and putting a bunch of stuff into spreadsheets and with Excel, and they weren't really utilizing what they were doing. One of the other problems was since everything was put on paper, by the time it got into the historian, it could be outdated because they only had, I think, 2 weeks worth of data, right? So they got with a partner of ours in Europe called Factory, and they got a new data historian, and that's built with InfluxDB. And Factory built that historian using a OPC UA connector, so that they could pull from all of these different machines that they have. They would have machines from Siemens, from Rockwell Automation, Schneider Electric, all these different machines and sensors, and they pull all that in with the OPC UA collector, bring it in InfluxDB, and then they set up dashboards in Grafana. And what they're able to do with those dashboards is everybody within that plant is able to see the data that they need. So if I'm working on machine A, I have a dashboard for the performance of machine A. If I'm the manager over machines A through E, I have a dashboard that shows what's happening with all those. If I'm the plant manager, I see everything that's happening in the plant. All that data is going into Postgres, and they're able to see all their data. So they could combine this easily with other data within their organization. They can monitor all aspects that we showed before, like the DevOps. They can monitor their performance of every aspect of their business in one place, like by bringing this IoT now into the equation. We've seen some really cool use cases with IoT. Recently, we had a company that told us the story. They thought they lost 800 pounds of magenta ink, which, as you can imagine, that's a lot of money. But as they implemented InfluxDB and started pulling sensor data in, they found that there were two problems with that conclusion. One, they had taken into consideration the viscosity of the inks. This helped them identify that the magenta had a different viscosity than yellow, and it took much more magenta to cover a page than it did yellow, for example. And the counters are mechanical. So as we know, anything mechanical has degrades over time, and it wasn't counting properly. So they weren't really missing this, but they thought they were. And what they were able to do is they were able to align their business costs with their costs they're passing on to the customer. They now knew magenta cost more, so they were able to build that into their quotes and their proposals. Yeah, so I mean, really just I'm always amazed I'm always amazed when I hear how customers are using InfluxDB and what they're getting out of it. I never in a million years would have thought that what we're building is going to go on and help, a company identify how much ink they're using. Or like our customer World Sensing, they have sensors set up. They're building smart cities, and they're able to see how systems within cities are performing. And they're also able to identify, and use machine learning to predict traffic patterns, to help parking companies figure out when their biggest needs are going to be, and how people, how they can organize their scheduling for parking. They're able to help first responders get to a scene that they need to be at as quickly as possible, all through collecting this time series data and what they're able to do with it.
Yeah, that's awesome. I mean, I remember 4 years ago talking about, how DevOps practices and toolings fit in the IoT world. And so it's really cool to finally hear use cases. Plus, you reminded me I need to buy ink for my printer at home. I cuss every time I have to get ink. Anyways, now I know about magenta. Now I'm going to make sure I never use magenta.
Now you know why you're paying more for magenta, right?
Yeah. So here's another question. And I always like it because as techies, we always want to know how things work, whether it's relevant to adoption or not. And usually in DevOps, it is very relevant. So can you tell us a little bit about the programming languages used to build these tools?
Yeah, InfluxDB is built on Go, so it's something that will work across many environments that you have. Our open source community is able to contribute easily to what we're doing because of the popularity of Go. Even though it is built specifically in Go, we have plugins that will enable you to use. You can use Ruby, you can use Python, you can use C++, anything that you can possibly imagine. Chances are there's a plugin that we have to ingest data using whatever programming language you're currently using.
Nice. And what about availability? Is there a connector available in AWS, for example?
Actually, for AWS and Google Cloud Platform, you can, with one click, deploy on those cloud providers. So you can search within the cloud store and find InfluxDB on Google Cloud and AWS.
Yeah, and we got asked that question by several people. So that's good news if it's right with the webinar, assuming if you're on AWS, you're at least somewhat in the cloud, if not cloud native. So That's fantastic.
For sure, it's quick and it's a quick, easy way to jump right in, and both of those are using InfluxDB 1.7 something right now. We do have a Influx 2.0, which is in alpha right now that you can play with as well. You can download from the website and play with now.
So the other kind of question I have as it relates to infrastructure again is, are there any considerations organizations need to make when it comes to how they need, so when they bring in a time series solution, how they need to make sure that their infrastructure and compute support that?
Really, the big thing is making sure that whatever you're connecting has a timestamp attached to it, right? It's only going to store and query information and data that has a timestamp on it. So from there, really, we have a simple line protocol that we follow, which tracks your measurement, the overall what you're measuring, everything that all of the things that you're measuring, which we call tags or tag sets, all the fields, the actual measurements themselves, and the timestamp. So it's a really easy template to follow for pulling in your data using that line protocol. But that's really going to be the biggest thing that you have, is making sure that your data is right for time series.
Yeah, which is interesting because it goes back to that point of there's the process of adopting tooling to solve an immediate need, but you also kind of have to think about the structure of your data, making sure that you have visibility into the future. And I'm really, the point about IoT and the growth of IoT, not just in terms of interest, but just the number of things out there, being able to support that. So there are a lot of other considerations that you have to think about in order to get an extensible and long-lasting solution beyond just hey, I need to collect data or I need to visualize data.
Absolutely, and one of the big things to look at is like you said, to plan for the future. You don't know what right now. We don't know what web and cloud native app development is going to look like in 5 or 10 years, but you're going to need something that can easily adapt, right? And something like InfluxDB that has this huge open source community that's continually contributing to what we're doing, it definitely lets us know that as things change, as new stuff comes into play, we've got the not only the team internally, but we have a community that's committed to seeing that we are able to adapt and we're able to incorporate those new technologies into what we're doing.
Yeah, that breadth of adoption, even across the open source world, is a really big deal.
For sure.
So I wanted to just kind of take a step back a little bit, and why don't we define, what it really means to be cloud native? Because I think that that word is thrown around a lot, but what about scenarios like multi-cloud, hybrid cloud?
Yeah, you really need a solution that's going to help with that, and that's where we were talking earlier about the adaptability of InfluxDB with Telegraf. Telegraf can pull from that hybrid cloud environment you have. It can pull your cloud native apps. It can pull stuff from on-prem. You just set up Telegraf to push that data, and you really need a solution that's going to help you, especially if you're just entering into the cloud native or you have a lot of legacy tooling that you're going to need monitoring. You're going to need something that's able to adapt to all of those environments, and that's how InfluxDB was built. InfluxDB is built definitely to help with, to work with cloud native architecture, but so much more as well. So much of the tooling you have is built for one or the other, and InfluxDB does a great job, again, utilizing Telegraf to pull that data from all sorts of data sources that you have, aggregating it together, putting it together so that you can look for correlation in what you're doing. Like we showed with Wayfair, for example, they're monitoring all of their internal DevOps tool chain, everything internally that they have. They're monitoring all their systems, their servers, their backend stuff, but they're also able to monitor all of their applications that they're building, cloud native, and their website and everything, and pulling all of that together to look at and compare, or to find correlation between things that pop up, and get a full view, get a view of their full stack. That's the thing you want. You really want to see your full stack in play. You don't want just your cloud native. You don't want to just monitor just your cloud native applications. You want to see everything together, and that's what InfluxDB brings to the table.
Yeah, and I've always been kind of shocked about how organizations, when they look even across their dev environments in a cloud native scenario, how little parity is considered. And when you're talking about your data, parity is absolutely critical. Not to mention being able to move from cloud to cloud and hybrid cloud and so forth. It is just I can't stress how important it is to consider, picking that tool that you can create parity, even if scale is not, a big concern in dev environments, and it's important to have that consistency. So
it is, and you don't want to get it, you don't want your tooling to lock you into a specific vendor, a specific architecture, or anything like that. You want a tooling that can grow with your business and adapt as you need it, and that's where a lot of the new time series platforms are able to help that traditional legacy monitoring won't.
Absolutely. Well, Tom, thank you so much for your time today. To wrap it up, just a few little more logistical points. For the questions that we didn't get to, we will, Influx Data team will get back to you with answers to those. This webinar was recorded, so make sure when you get the email with the link, you share it with your peers, because this is great, useful information, and on-demand webinars are always great for pulling up and listening to while you're doing some other work. And I really appreciate your time today, Tom, on talking about the importance and the difference of time series data in cloud native applications.
Thanks so much, Chris. It was fun.
All right, we'll chat soon.
Cheers.